on Fascinating Frontiers, episode 145. It's July 28th, 2026. The universe has been busy. Let's get into it. Radio telescopes have tracked space debris for the first time by listening for its own faint signals. Scientists used radio telescopes to detect signals from orbiting debris without relying on active radar. The approach succeeded on its first attempt. It opens a new passive method for monitoring crowded orbital regions where active transmissions are limited. That's the first time that's ever been done. Follow-up work will test whether the technique can scale to routine cataloging of smaller fragments. Now, shifting to distant worlds with surprising properties. Astronomers have identified gas giants with densities so low they compare to cotton candy or shaving foam. These worlds challenge standard models of how massive planets retain thick atmospheres at such low masses. The objects sit at the extreme low-density end of the known exoplanet population. Follow-up observations aim to measure their exact compositions and formation pathways. From atmospheric extremes in known exoplanets, the focus turns to possible volcanic activity on their moons. Io's volcanic gases travel along Jupiter's magnetic field lines and power its aurorae. The same process might produce detectable signatures around exoplanets if an Io-like moon orbits a gas giant. JWST's infrared capabilities could spot these volcanic emissions from light years away. Tidal heating driven by orbital eccentricity would supply the energy for ongoing eruptions. Confirmation would mark the first indirect evidence of active exovolcanism. JWST observations could reveal volcanic exo-Ios by detecting sulfur compounds and other gases stripped from a moon's surface and funneled along a giant planet's magnetic field. The same mechanism powers Jupiter's auroras, so a scaled-up version around a super Jupiter might produce a detectable infrared glow. If confirmed, these signatures would give the first indirect evidence of active tidal heating beyond our solar system. Could similar moons exist around the growing population of directly imaged gas giants? The satellite captured extensive burn scars near Bordeaux and around the Cebreros ground station on July 26th. Sentinel-5P data showed elevated aerosol levels over southwestern Europe. Operations at the ground station resumed despite nearby fire activity. The imagery provides a rapid damage assessment for emergency responders. Aerosol maps help track how smoke disperses across the continent. Material returned from the moon's far side shows the two hemispheres experienced different space weather histories. Earth's magnetic field apparently slowed solar wind particles striking the near side. The samples provide the first direct record of far-side regolith evolution. Differences in solar wind exposure appear in the abundance of implanted volatiles. The data refine models of how the Earth-Moon system interacts with the solar wind over billions of years. NASA's Escape Aid mission imaged Earth and the Moon together during its early cruise phase. The view offers a calibration target and public outreach image before the spacecraft heads toward Mars. The twin spacecraft will study the Martian magnetosphere and atmosphere after arrival. The portrait demonstrates instrument performance ahead of the primary science phase. The mission concept has matured from an initial proposal into a detailed plan for a large aperture ultraviolet visible near-infrared observatory. Its primary goal is to characterize potentially habitable exoplanets and search for atmospheric biosignatures. Engineers are now refining the coronagraph and mirror technologies required. The observatory would be the first space telescope designed specifically for this task. Technology demonstrations are scheduled to reduce risk before the final design review. A new study finds star formation in Andromeda has dropped steadily over the past 500 million years. The decline steepened further in the last 40 million years. The galaxy lies 2.5 million light-years away and serves as a nearby analog for Milky Way evolution. Hubble's multi-wavelength imaging allowed astronomers to age-date stellar populations across large portions of the disk. The results help calibrate models of how spiral galaxies quench star formation over cosmic time. Technicians completed fueling at Kennedy Space Center's Payload Hazardous Servicing Facility on July 25th. The observatory remains on track for a late August launch. Post-separation maneuvers will rely on this propellant load. The 290 gallons will support orbit adjustments and station keeping once the telescope reaches its operational halo orbit. Final integration and testing continue ahead of the launch window. New analysis indicates Mercury occasionally develops radiation belts similar to Earth's Van Allen belts. The belts appear when the planet is farther from the Sun and its magnetosphere is less compressed. University of Michigan and UC Berkeley researchers identified the short-lived structures in existing spacecraft data. The discovery overturns the long-held view that Mercury's weak field cannot trap energetic particles. Future missions will search for similar transient belts during the next solar cycle. JWST discoveries of compact red objects could represent early globular clusters, each centered on a supermassive star. This interpretation differs from earlier suggestions that the objects were galaxies or black hole hosts. Further spectroscopy will test the cluster hypothesis. The clusters would have formed when the universe was only a few 100 million years old. Their survival to the present day would constrain models of dynamical evolution in dense stellar systems. Western Australia's Yilgarn Craton shares geological features with lake basins in Mars' Terra Sirenum region. Researchers mapped mineral and sediment patterns to reconstruct how water once flowed and evaporated on the red planet. The comparison helps refine models of Mars' past habitability. Evaporite sequences and channel deposits on Earth provide analogs for features seen from orbit on Mars. The study strengthens the case that similar aqueous processes operated on both worlds. Observations indicate some white dwarfs continue accreting material from disrupted planets and asteroids at higher rates than previously modeled. The findings expand the use of these stellar remnants as probes of ancient planetary system architecture. Metal lines in their spectra reveal the bulk composition of the accreted bodies. Some systems appear to deliver debris steadily for decades. The data suggests that planetary material can persist through the star's red giant phase in greater quantities than expected. A typical white dwarf packs the mass of the Sun into a sphere the size of Earth, creating surface gravities strong enough to pull in any nearby debris. When a star leaves the main sequence and sheds its outer layers, surviving planets and asteroids can be perturbed into crossing orbits. Over time, fragments spiral inward and vaporize in the star's thin atmosphere, leaving detectable traces of elements such as calcium, magnesium, and iron. One white dwarf has shown ongoing accretion for decades, implying a steady supply of material equivalent to a small asteroid every few years. The process turns these stellar remnants into cosmic laboratories that record the bulk composition of planets that formed billions of years earlier. Yet astronomers still cannot explain why some white dwarfs display almost no metals while others remain heavily polluted long after their planets should have been cleared. The pattern suggests entire planetary systems can survive the star's death throes only to meet a slow, dusty end. Researchers examined 800,000 DEESI objects and flagged 7 candidates where a foreground galaxy gravitationally lenses a background quasar. Quasar lenses remain rare because the bright central engine usually outshines the lensing signature. Follow-up imaging will confirm which candidates are genuine. Gravitational lensing allows astronomers to measure the mass distribution of the foreground galaxy and study the quasar at higher resolution. The search demonstrates how machine learning tools can accelerate discovery in large surveys. Recent surveys suggest free-floating worlds that orbit no star are the galaxy's most common planet type. These objects likely formed in circumstellar disks before gravitational encounters ejected them. Their abundance implies planet formation is even more efficient than star formation. Microlensing surveys have detected several candidates, with masses ranging from Earth-like to several Jupiter masses. Future wide-field surveys will refine the total population estimate. Keep an eye on the next round of Roman Space Telescope integration tests ahead of its late August launch window. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. This show comes to you from the NARA Network. If you want another sharp daily briefing, Tesla Shorts Time has you covered. Your daily deep dive into everything Tesla. All our shows are free at naranetwork.com. Prefer reading? Today's full write-up, sources, and transcript are on the episode blog at naranetwork.com. Same briefing, readable format. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through